See, friends, when a memory leak happens, there are some symptoms you're going to observe in your application. What are those symptoms, right? So let's review that. There are 4 symptoms, my friends, your application will start to experience when a memory leak is happening in your application. See, this is an memory behavior of an application which is very healthy, right? Why do I say this is a memory behavior of an healthy application? Look at this. As requests are coming, the memory is building up. Memory keeps on building up. This red triangle indicates it's a garbage collection event. It's a full garbage collection event. When garbage collection runs, it reclaims the memory, right? When this full garbage collection event ran, the memory dropped all the way to the bottom. And then once again, the memory starts to build up. When another full garbage collection event ran, the memory dropped all the way to the bottom. You see this beautiful sawtooth pattern, memory going up, coming down, going up, coming down, right? And if I try to draw a line connecting all the bottom points, it is that black dotted arrow. You can see this is going at a kind of a 0 degrees, right? It's going at a 0 degrees. Now, let's look at how the memory behavior pattern of an application which suffers from memory leak, how it's going to look like. And this is how it will look like. You will see a gradual memory increase. See, look at this. The request is coming, the memory is building up. Now it has gone to this 8 GB limit because this XMX, the heap size for this application is configured at 8 GB. So it cannot go beyond 8 GB. So it went here and then it dropped. Look where it dropped. Initially it dropped to 4 GB. Now, once again, the memory is building up. Now, next time when the event ran, look, it is dropping to 4.5 GB. It didn't drop to 4 GB limit. It's dropping to 4 GB limit. And now it becomes 5 GB. 5.5. So you can see that bottom point is gradually increasing. So if I try to draw a line, slope connecting all the bottom points, look at this black arrow. It is almost going at a kind of a 10 degrees, right? It's almost going at 10 degrees. Whereas the earlier one, this one was going at 0 degrees. So what you will see, you will start to see this kind of an memory, the bottom point starting to go like this, going at an inclination. So this is a clear indication that this application is suffering from a memory leak, right? But it hasn't just blasted. The problem hasn't really worsened, right? But when this application continues to run, the application with a memory leak, when it continues to run, this is how the memory behavior will start to look like. You can see it's going up and down after a point. You can see the garbage collection, the red triangle, it keeps on continuously running. There's no gap in between them. You can see it is continuously running, but still the memory is not dropping. It keeps on going like that. Friends, when one full garbage collection event runs, that is, even when there's one red triangle runs, it consumes enormous amount of CPU cycles because garbage collection is a heavy CPU intensive operation. Look what the garbage collector has to do. Our application is creating millions of objects. It's creating millions of objects. Now the garbage collector has to examine all those millions of objects and see whether those objects have any references. Because if there are objects with references, it shouldn't remove that object from the memory. So it has to check what are the objects which has the reference. Okay, so let's say there's an object here. So now it's going to go, the garbage collector will check, whether this object has any references. Yes, maybe this object is referenced by 3 other objects. Now then, the garbage collector has to go and check all those 3 other objects as well to see whether they have any references. Like this, it has to walk that entire hierarchy to see whether there are any active references for the object. If there's no active references, then it has to be removed from memory. So it has to walk through all these objects and the reference chain. So it takes a lot of CPU cycles. Even when one red triangle runs, the CPU will be going high, like a 90-95%, and then it will drop. Whereas here, look at this, what's happening. Here, the red triangles, that is a full garbage collection, are continuously running. They're continuously running. The CPU consumption will be at a 95, will be at a close to 100%. Will be close to 100%. So it keeps on going like this. So CPU will be 100%. Friend, this is a golden rule. Remember always, whenever a memory leak worsens, always CPU will also spike up. It's interconnected, right? When there's a memory leak and it really worsens, the CPU will also spike up and it will remain at 100%. If CPU spikes up, you didn't make any code change, nothing. If CPU spikes up and goes to 100%, remains there, there's a very good chance it's a very good indication that your application is suffering from a memory leak. So this is a second symptom. You're going to see elevated CPU consumption when memory leak really worsens. And the third symptom, what happens to your application is you will start to see a degraded response time and timeouts will start to happen. Because, my friends, when a garbage collection event runs, it stops your JVM. It actually pauses your JVM. Like you want to visualize as if you're watching a YouTube video clip. You're watching a YouTube video. If you click on the pause button, what will happen? The video will not play, right? Similarly, when garbage collector runs, it stops your JVM. It stops the JVM because if it doesn't stop, your application threads will keep modifying the objects. We always create objects. We rechange the pointers. Application does this always. So garbage collector cannot proceed if application thread is meddling with the object pointers. So it stops the JVM. But here, if you see, when towards the right side, besides the CPU consumption, it's also stopping the JVM. So here you can see continuously the JVM is getting stopped. The JVM gets continuously stopped. So what's going to happen if it's stopping? The JVM gets stopped. That means any customer transaction which is coming, they will not be processed. Or what are the customer transaction in motion? They will not get a response immediately. So your response time will start to degrade. And if in this kind of, towards the right end of the graph, if you see, it is continuously pausing. If it's continuously pausing, you'll start to see timeouts. So your health checks can also start to fail. So this is the third side effect of memory leak. And finally, the final symptom is when problem really worsens, there's no more objects can be created. At that point, JVM will throw out of memory error. It will throw out of memory error in your application. Right? This is the final resort, what JVM does. So to recover the situation. So you get out of memory error. So in a nutshell, there are 4 symptoms. The first symptom is you're going to see a gradual memory increase. And when the problem really worsens, you're going to see a CPU spike and poor response time and timeouts. And as a final result, your application will experience out of memory error, right? So these are the symptoms.